Hello people, welcome to Gurukula. I'm Jai. So today in this video we are going to see about IPv4 addressing. So without any further delay, let's get into the topic. So whereas in our previous videos we were talking about all the concepts that is related to the data link layer. So now we are into a new layer, that is what we call it as the network layer services. And in network layer service, the very important property or the very important protocol which is responsible for the proper delivery of messages from one node to another node which is located on some other network is what happening. It's all because of this internet protocol. So that V4 represents it is Internet Protocol version 4. On the other hand, we have IPv6 as well, which is Internet Protocol version 6, which will be discussed in the later part of the videos. But today, in this video and in the next subsequent videos, we will be talking about what Internet Protocol version 4 is and what are all the various subnetting options that is available in IPv4. So with this note, let's get into the topic today. So the things that we are going to cover regarding IP address, which means Internet Protocol addresses, we will first of all throw some light on what is IP address, and then we will try to understand what is the need for IP, and then we will try to understand the representation of IP addresses and what are all the various classes that is available in IP address, and then finally we will see what is subnetting and what are all the types of subnetting and how important the subnetting is as far as the network field is concerned. So all these things we will be discussing that is related to IP addresses. And please do remember that considering the length of the video, all these contents will not be covered in this single video, whereas we will be covering what is IP address and then what are all the various representations only in this particular video. The remaining concepts will be covered in the subsequent videos. So just to introduction of an IP address is nothing but it is of 32-bit length. So it is an 32-bit address that identifies a connection to the internet. So let's take for an example, let us say that a system called A and then there is a system called B over here. And when I say that these two systems are connected, as far as human being purposes, we can call this as system A and then system B. But a network will understand that this is a system and the address of this particular system is based on only the IP address. So this system must have an IP address and this system should also have an IP address which is of 32-bit length. And when I say address, it is obvious that no two systems on the internet should have a common IP address or the same IP address. So obviously all the IP addresses are universally unique. So how many IP addresses that we can have is it is quite a simple math. We have 32 bits of addresses. So 2 raised to the power 32 will have approximately 4 billion IP addresses we have in our hand. So that is what a very basic introduction of an IP address. And then we will see why is IP address needed. It is as simple as that. So when we roam in a city or when we wanted to find out the address of a particular person, we need that particular address, which means the location. I'm talking about the location. Let's take for an example, I wanted to identify where exactly my friend is. So that I will ask him, where are you? And so that he will be responding me back with the address of that. He will give me the different parts of the address. He will give me the door number, he will give me the area code, he will give me the street name and then municipality, city and then the state and then the country. So the address what my friends give is divided into various components and each and every component will give me one part of information which will help me to identify the overall location of that particular person. So what if there is no IP addresses and what if the IP address has been lost, which means we can say that the packet is lost on the internet. So without knowing the IP address, we can say that a packet could not be delivered to the correct person. So let's take for an example, you are ordering something on Amazon or Flipkart. So what if the delivery person does not know where you are located? He doesn't know the address of your home. So how can you ensure that the packet is reaching your home? So it is that important the IP addresses are as far as network is concerned. So how IP addresses are used for identification. So let's take for an example. I am sitting in India, and then I wanted to surf for some pages. Let's take for an example. I wanted to surf google.com, whose server is located in California. So where am I located? I will be located somewhere in one network which is located in India, and in that network I will have my laptop, which I call it as an host, that is connected to that particular network. And then out of several processes running on my laptop, I will be initiating the network traffic only from one process. We call that as process ID. The same setup will be available on the other side as well. You will have several networks at California, and out of which my Google server will be located at only one particular network. And even that the server is nothing but a high configuration system. So again, I can call that as a host, and that will be running several processes, out of which I am going to access the search engine. So the query what I will be sending from my system to the server is www.google.com. So this request will be sent from my side, and this request will be addressed from the California. I will be getting the Google site on my screen. This is how the simple query will work. But my question is, where does the IP address comes into this picture? So here, this www.google.com, this is really fishy. So say for an example, as a human being, we can understand the words. So that is, I am asking for www.google.com, and this is what something we call it as domain names. So it is very easy for us to remember anything with a name. So these are all is what we call it as domain names, and whereas unfortunately the systems will not understand any of this kind of domain names. So that is where actually another principle, a small principle, comes into the picture. We call that as DNS, that is domain name servers. So these domain name servers are giant dictionaries, or the giant phone book, I can say, where this will be storing what is the IP address of each and every domain. So what is happening is, instead of this particular request directly getting delivered to California, this will be given to the DNS server first. So www.google.com will be given to DNS server, and my DNS server will look up its entire table, and then that will respond me back with an IP address like this. There you can see an IP address. Yeah, so this IP address will be replaced in places of the destination address, and then that frame will be sent over the internet. So this is what happening at the background of the internet, and this is very much important to understand at this point, so that we can take the classes very further. Fine. So IP address is available for each and every system that is connected on the internet. So without IP address, it is not possible for us to identify on which network the system is located, and even on which host the process is getting running. So IP addresses are very much important to identify any node that is connected on the internet. So since IP addresses are nothing but the 32-bit numbers, then definitely the numbers has to be arranged in an organized way. So how is it organized? Let us take for an example, there are few number system which is already, we find it in an organized way. So here is an example of a telephone number, and you can see that each and every bit or a group of bit has different representations. So whereas the first three digits, that is +91, represents the country code, and 97 represents the access code, and 904 represents the next three bits represents the service provider, and the last 5 digits represents the subscriber number. And similarly, when you take another example such as pin code or zip code, you can see each and every bit will have their own functionalities. And similarly, when you take any register number that is allocated to a student in India, you can see that it is organized in such a way that the first 4 digit represents the college code, and then the next 2 digit represents the year of admission of that particular candidate, and the next 3 digits represents the subject or the branch code. So 106 represents for ECE, and the last 3 digits represents the student's number. So this is how any number has to be organized. So the same principle is applied for your IP addressing as well. We cannot simply put 32 bits of number in a randomized way. So how do we put the 32 bits of address is classified into two halves. Few bits will be representing the network ID, and few bits will be representing the host ID. So how many bits represents network ID and how many bits represents host ID, we will be discussing it in a little later. So coming to the representation of IP addresses can be represented in two forms. One is the binary representation and another one is dotted decimal representation. So where the binary representation and dotted decimal representation is shown in the figure for your example is concerned, and in most of the situations as far as human understanding, it is easy to note it down the IP addresses in the decimal representation itself. So for the human being, it is easy to read the numbers in a decimal format, but systems will always go for the binary representation of the IP addresses. The binary representation is nothing but 128 is simply converted to binary. So these are all the two representations of IP addresses. So now we will get forward and then we will try to understand what network ID is and then what host ID is. So there might be few bits that is representing on which network it is connected, and there will be few bits that is representing how many number of hosts are connected. Network I am calling like say for an example, this is a particular network, this is net 1, and let us take for an example this is net 2, and let's take for an example this is net 3. So here 3 networks are connected, and let us assume that this network has 4 PCs like 1, 2, 3 and 4. So now there should be few number of bits to represent which network I am talking about, and this is what we call it as net ID, and then in short I will call it as NID, and then for each and every host connected in this particular network will have an ID, that is what we call it as host ID, that is HID. So network ID represents which network it belongs to, and then in that particular network there will be several hosts connected, and with the help of host ID or the host ID bits we can identify which host we are talking about. So this is what a basic explanation of what net ID and then the host ID is. So initially when the IP addresses were introduced, it was blindly calculated as out of 32 bits there were 8 bits allocated to form a network, and then 24 bits is allocated to form a network, so to form a host here. So as you can see here, 8 bits are used to find out the network, and then 24 bits is allocated for the host. If this is the case, then what could be the maximum possible number of networks that we can create? So as you can see, since I have 8 bits, you can have 2 to the power of 8 networks, which is approximately 256 networks that I can create. And then with 24 bits that represents the host part, I can create 2 to the power of 24. So approximately 16 million hosts can be connected in one network. So that is what the total address space that we had in IPv4 configuration, but unfortunately this was not scalable. So let's take for an example, not all the organizations or the institutions will require the same amount of IP addresses. So the organization and institutions will be of different sizes. So I must have different sizes of network and different sizes of hosts that can able to connect on a network. So that is where actually the class full addressing comes into the picture. Now we will try to understand how the address space is maintained and it is managed to divide into class full addressing. So we very well know that we have totally 2 to the power of 32 addresses. When I talk about IP address, it is totally 32 bits length. So 2 to the power 32 will be the total address space what I have. So everything, so I guess everyone will be clear with this. So totally I will have 2 to the power 32 addresses, and what I will have to do is I will have to divide this entire addresses into 2 blocks. So how can I divide that into 2 blocks? So what we can do is, let us try to understand with a simple example. What I will do is I will write binary numbers from 000 to 111. So starting from 000, 001, 010, 011, 100, 101, 110, 111. So now when I have to divide this entire address space into 2 blocks, there must be some identification for me. So what I will have to do is I can divide it over here. Now what makes a representation? I can name this particular group. I can say this particular group of bits is starting with 0, and I can say that this particular group is starting with 1. So the number of the bits starting with 0 will be treated as one group, and then the number of bits starting with 1 will be treated as the different group. So in order to divide the set of numbers into two groups, I need one binary value to divide that into two groups. So if it is 0, I can say that as one group. If it is 1, I can call that as another group. So similarly, in order to divide 2 to the power of 32 addresses, I will take one bit to divide that into two halves. So what I will do is I am dividing the entire 2 to the power 32 bit addresses into two halves, whereas the first half will always start with 0 and the second half will always start with 1. So having one bit allocated for grouping, we will have remaining 2 to the power of 31 number of addresses in the first block, and then 2 to the power of 31 addresses in the second block. So now what I will have to do is, you should not alter anything in this particular block. You will keep this particular block as such, and then I will further divide this thing into two blocks again. So now what I will have 2 power 31 addresses here, and then I will take it forward, and then I will try to divide only this 2 power 31 addresses again into 2. So how do I again further classify it into 2? Now here already all the bits in this particular block is starting with 1, so that this particular bit is always 1. We cannot change this. Again, now I want to divide this into two groups. So what I will have to do, I will have to add another bit, or I will have to take another bit in order to divide that into two groups. So here again I will have 0 and then the 1. So I will get two groups here. So first group will be starting with 1 0, and then the second group will be starting with 1 1. So now two bits are allocated for grouping, so that remaining I will have 2 power 30 bits in hand. So remaining I will have 2 power 30 bits in hand in the second group also. Yes. So now what I will have to do is, I will have to repeat the same procedure. I will not alter this particular block. This particular upper block will be kept as such, and then I will take only the bottom part, and the bottom part will be again classified into two. So doing that, I will have totally 2 to the power 30 addresses. Now I have 1 1 as constant. I will have to divide the group into 2. So I need one more bit. So I will have like this. So the first block will always start from 110, and the second block will always start with 111. So giving 3 bits for grouping, I will have 2 to the power 29. So this 29, again the bottom part has to be further classified into 2. I am not altering anything in the upper part. The upper part of the block is kept constant, and I am just dividing this 2 to the power 29. Further I am classifying into 2, so that I will end up with 2 to the power 28 addresses. Now what you can see is this particular upper part alone. So this particular 2 to the power 31 addresses is what we call it as class A address. And then this particular upper part is what we call it as class B address, and this upper part is what we call it as class C, and this block is what we call it as class D, and bottom part is what we call it as class E. So the total IP addresses is divided into 5 classes of address, that is class A, class B, class C, class D, and then class E. So class A addresses will always start from all zeros to 127, which means the first bit is always 0 as far as class A is concerned, so that 0 is marked as red. You have to freeze that. So what will be the starting number and then the ending number? So starting number will be all zeros, so that is the decimal value is 0, and then it can run up to all ones, so that the decimal value is 127. Similarly, when you write it for class B, you will get from 128 to 191. And for class C, it is 110 is constant at all times. The remaining bits may run from all zeros to all 1. So you will get 192 to 223. And for class D is concerned, it is 1110 is freezed. And then the remaining 4 bits can vary from all zeros to all 1. So you will get 224 to 239. And for class E, it is 240 to 255. So this is how the classes is being organized in the IP address space. So this is an overall picture which will help you to identify which class of IP address that is given to you. Let's take for an example, if an IP address is given to you, let's take for an example 192.168.10.5. let's take for an example that if this is an IP address that is given to you, and if you are expected to find out which class of IP address is this, you can simply take the first byte alone. Take the first byte. What is the first byte? It is 192. So if it is 192, you can clearly see that where is this 192 coming in, and you can see that 192 to 223 belongs to class C address. In case if this is given in decimal number, you will have to check for this particular case. In case the first 3 bits are 110, then you can blindly say that the given IP address is belonging to class C IP address. So if the IP address is given in decimal format, and then if it is runs from 0 to 127, you can say that it is class A, and then if it is from 128 to 191, you can call that as class B, and if it is from 192 to 223, it is class C, 224 to 239, it is class D, 240 to 255, you can say that as class E addresses. And in case if it is given in binary, you can check for this particular condition and you can map it with the corresponding classes of address. Now this particular exercise will help you to identify given an IP address, what will be the class of that IP address. You can easily find out that. So next we will try to identify what makes the difference. Fine, now we understood that the entire 32 bits of addresses is classified into 5 classes of IP address. Now what is the difference in this 5 class? As of class A is concerned, you can see that only the first byte is allocated for network address and the remaining 3 bytes of addresses is allocated for the host ID. So I will have only 8 bits to represent the net ID, and then the remaining bits, 24 bits, will be allocated for the host ID. And as far as class B is concerned, I will have 16 bits allocated for net ID, and then I will have equal 16 bits allocated for host ID. And then as far as class C is concerned, you can see that there are 24 bits allocated for network and then only 8 is allocated for host ID. So this makes the difference. And as far as class D and class E is concerned, there is no separations of net ID and then the host ID, whereas class D is completely utilized for multicast addresses, and for class E it is completely utilized for the reserved for the future purposes. We cannot use it for any other functions. So this is what we will have to understand. So now it's your time. So what I will do is, you can pause the video here and then you can try to find out. Yes, you can pause your video here and then you can try to answer the question. So how many network IDs and host IDs are present in each of the classes? So that is the question, and this is the figure. This is given for your reference. So you can pause your video here and then you can try to answer the question, but as of now I will just march forward. So as of net IDs is concerned, this is for class A is concerned. So this is for class A. You can see that out of 8 bits allocated in the net ID, 1 bit is constant. Yes, do you remember? We just used this one particular bits to segregate for grouping. So it will be all zeros, correct? So if out of 8 bits, 1 bit is always 0. So 8 minus 1, it is 7 bits. So 2 to the power 7, it gives you 128. So you can have 128 networks as of class A is concerned. Fine. Which means I am talking about this particular network. This is network 1, network 2, network 3, network 4 and so on. Similarly, you can have 100, and so you can have, this is network 1, and similarly you can have 128 networks like this in class A is concerned. And then in each and every network, this particular network can hold up to 16 these many hosts that can be connected in one network. So 2 to the power of 24. So 24 bits is allocated. So these many hosts can be connected. So that is what the maximum number of net IDs and host IDs that can be connected in class A. And as far as class B is concerned, you will have 16,000 something in net ID. And then as far as class B is concerned, the host ID is around 65,000. And for class C, you have comparatively more number of bits in the network part. So you can create more number of networks in class C, and you have less number of host ID, so that you will have only 256 addresses for the host ID. So that is what we call it as the net ID and then the host ID. So depending upon the requirement and depending upon the organizations, I can choose which class of addresses I will have to use for my system. So this is a summary of all classes. You can take a screenshot or you can pause the video and then you can just observe this particular table for your references, and for solving the problems this might be very useful. So next to talk about the IP address. Okay, fine. How many IP addresses will be there in class A? So just to understand how many IP addresses will be there, this diagram will help you to understand the blocks. So let's see for an example that this is net ID 0 block. It starts from all 0 and then it runs up to 127. Correct. So each and every net ID we will be talking it as, say for an example, as far as class A, only the first 8 byte represents the network ID. So each and every number in net ID represents one particular block. Let's take for an example number 73. So if 73 is kept constant, you can see that it runs from all zeros to all ones, which means that 73.0.0.0 to 73.255.255.255 will be treated as one network, right? So what will be the IP addresses running in it? So this will run up to 73.0.0.0. What will be the immediate next IP address? It will be 73.0.0.1. Likewise .2, .3, it runs up to .255. After 255, it will run from 1.0, then 1.1, 1.2. Likewise it goes on. So likewise it comes for 255 to 255. Later on it will be 1.0.0. It goes up to 255.255.255. For all these things it is 73 in common, right? So totally 73.255.255.255. So these many IP addresses are there in class A, that is only for one block. So similarly you have 127 blocks. Yeah, so that many IP addresses are there. So totally you have 128 blocks in class A address, and then in each and every block you have these many addresses in one particular block. So now I think you can visualize numerically how many addresses are there in class A alone. So next, one thing which has to be kept in mind is only one block, which is net ID 10, is kept for private addresses. As of now, we are not getting into the discussion of what public address and what private address is, which is kept for the later discussions. You can check the network's description for the further discussions of what private address and then the network addresses are. And similarly, as far as class B is concerned, you have 16,384 blocks, and in each and every block you have these many addresses. And for class C is concerned, you have these many blocks, and in each and every block you will have only 256 addresses. So that is what the address space of class A, class B and class C. So let's take a simple exercise here. Given the network address, that is 17.all0, you are expected to find out what is the class, what is the block, and what is the range of the IP addresses. So by looking into the number, I can say that it starts from 17. So if it is 17, I can clearly say that it belongs to class A address. Correct. And then talking about the network ID, what is the network ID? As far as class A is concerned, only the first byte represents the network ID, and then the remaining thing represents the host ID. So net ID is always 17, and if I put all zeros for host ID, I will get the block address. So the block will be running from all zeros to all one. So 17.all zeros to 17.all ones. So that will be the address block for the given network address. Now let's take another example. You can pause the video here and then you can try answering this particular question. Identify the class, block and then the range of the address. So now looking at the IP address, you can see the first byte. The first byte starts from 132. So when I talk about 132, it belongs to class B address. Once the class is identified, you very well know that class B will have 16 bytes, which means 2 bytes of information represents the net ID, and then 2 bytes of information represents the host ID. correct? So what will happen? The host ID can run from all zeros to all ones. So 31.21 will be kept constant. So it runs from all zeros to all ones. So that is what we call it as the total address range of class B. So similarly, for another example, you can pause the video again here. You can try to find out what will be the network address here. So given the number, it is 220.34.76. So here you can see that this belongs to class C. And then as far as class C is concerned, the first 3 bytes represents the network ID. So you need not change the 3 bytes. So 220.34.76 has to be kept constant, and it varies from 0 to 255. So that will be the address range of this particular address block. And also, not all the IP addresses that is in the block is usable IP addresses. When we talk about usable IP addresses, the very first address of the address block will be given for network ID that represents the network, and then the last IP address of the block represents the broadcast address. So let's take for an example, let us take a 10.network. So 10.0.0.0, and we know that it runs from 10.255.255.255. So this is the very first IP address which cannot be used for assigning to any host, and this is the last IP address which is also cannot be used for assigning to any hosts, which means that the very first address represents the network ID, and then the last address represents the broadcast ID. So these two addresses cannot be used. So fine. So when we talk about broadcast address, there are 2 types of broadcast addresses which we have to address. So what are all the 2 types of broadcast? We have limited broadcast. What is limited broadcast? When you looking into the figure, you can clearly see that whereas one particular node wants to send its information to all the systems connected in the same network. As you can see, this is the network ID is 11.allzeros. So this particular node wants to send its frame to all of the remaining nodes present in the same network. Then I can call this as limited broadcast. So the limited broadcast address will be all 255. When I put all 255s, then that represents that, or the frame will be delivered to all the systems connected in that particular network. The other type of broadcast what we have is directed broadcast. So what do you mean by directed broadcast? This is the scenario. So whenever I have a system that is located in 11.network, and this network wants to send its data to all the systems connected in 20.network. So when a system located in different network wants to broadcast its frame in a different network, then in that case we call it as a directed broadcast. So directed broadcast, what you will have to do, the first network ID has to be placed, and then instead of host ID I will have to put all zeros. So since this belongs to class A, as far as class A, the first represents the net ID. So I wanted to broadcast my frame in 20.network, so I will put 20 over here, and then I will have to broadcast. What do you mean by broadcast? If it is all ones, then it will be broadcasted. So it is all ones over here. So that is what we call it as directed broadcast. So you can understand the limited broadcast and directed broadcast with this simple exercise. What you can do is you can try filling this table. You can pause the video here, and then you can try to fill the table with the network ID given the IP address. I will solve one problem for you. You can solve it for the remaining things. So what you can do is given the IP address, that is 1.2.3.4. So what will be the network ID? By looking into the IP address here, I can clearly say that this is 1, which means that it is class A IP address. So as far as class A IP address, the first byte is network and all remaining things are host IP address. So what will be the network ID? I will have to put all zeros for the network ID. So 1.allzeros will be the network ID. So that is correct. What will be the directed broadcast? In case if someone wants to direct broadcast in this particular network, what will be the direct broadcast address? Again, one will be the network ID, and then if I have to broadcast, then I will have to put all 255 in the host part. So this is the host part as far as class A is concerned, so I will have to put all ones over here. So 1.255.255.255 will be treated as directed broadcast address. And what happens if it is limited broadcast? Limited broadcast represents I will have to broadcast within this particular network, so the broadcast address will be all 255s. So likewise, you can fill it for the remaining tables as well. So the remaining tables, next is also 10.15.20.60. Again, this belongs to class A address. So the network ID will be 10.all zeros, and then the directed broadcast address will be 10.all 255, and then what will be the limited broadcast? The limited broadcast will be all 255. And next comes 130. 130 belongs to class B address, so 130.1 has to be kept constant, and then the network ID is like this, and then the directed broadcast is this, and then the limited broadcast is like this. Now I will reveal answers for all the tables over here, so that you can have a clear understanding of what directed broadcast is and what limited broadcast is. So now an interesting thing comes. So what will be the answer for this 250.0.1.2? So this does not belongs to any class A, class B or class C. So net ID broadcast ID is not possible as far this IP address is concerned. And then the last IP address, that is 300.1.2.3, which is an invalid IP address because the IP address will have a maximum value of 255, whereas we have only 8 bits, and putting all ones for all the 8 bits you will get only 255. So 255 will be the maximum value that can appear in an IP address. So 300 cannot be possible. So I guess you all people will be understanding what IP address is, the length of the IP address, the class of IP address, what are all the various classes, and how different classes is being organized by the use of net ID and then the host ID, and what is an broadcast address. And there are two types of broadcast address, one is directed and another one is limited broadcast address. So with this I am winding up this particular video, and then I am going to see you in the next video. Until then, it's bye from Jay, and then happy learning.